The number of cycles per second is known as frequency and is measured in hertz. The device used for displaying frequency is the oscilloscope. So, if one cycle of a radio wave takes 1 second to be completed, the wave will have a period of 1 second and a frequency of 1 hertz. If there are 1,000 cycles per second, the wave will have a period of 1/1000th of a second and a frequency of 1,000 hertz. If a radio wave takes 1/8 of a microsecond to complete, one cycle, that is 0.125 of a microsecond, we can see that it has a frequency of 8 million cycles per second, or 8 million hertz. Because these figures for radio wave frequencies are always so large, they are expressed in a more convenient way as kilohertz, megahertz, or gigahertz. So instead of saying that a radio wave has a frequency of 8 million cycles per second, we can now say that it has a frequency of 8 megahertz, written as you see on screen. The wavelength, or length, of a radio wave cycle is the distance between the start and the end of the cycle, generally shown as the distance between the peaks of two successive identical waves. It is denoted by the symbol lambda. The number of times that a wave is repeated during a second has a direct correlation with its length. The longer the wave, the fewer there can be in a second, and the shorter the wave, the more there can be in a second. In other words, wavelength and frequency are inversely proportional to each other. Therefore, wave frequency, measured in hertz, and wavelength, measured in meters, are directly related, and we need to be able to calculate one from the other. The formula for calculating wavelength, lambda, is the speed at which a radio wave travels, c, divided by the frequency of the wave, f. In order to be able to do these calculations, we need to recall that radio waves travel at 162,000 nautical miles per second, or 300 million meters per second. This figure in meters per second is the one to use in all calculations. The formula for wavelength is simplified to 300 divided by frequency in megahertz, giving an answer in meters. You may need to convert the data given from kilohertz or gigahertz into megahertz. The formula for frequency is 300 divided by wavelength in meters, giving an answer in megahertz. You will need to convert the wavelength into meters if the wavelength is given, say, in centimeters.